Hello, this video is for Trig section 9.1. Now to ease into this concept, we do a little refresher from our college algebra material here. So if you remember these problems in college algebra, we said there kind of was a workaround where you could FOIL it all the way out. But the reason that we tried to emphasize this other way, not only was it shorter and easier, but it's the idea we're going to use for these more complex trig problems and other problems that you might encounter later in math. So the idea is that they don't just have a single variable being squared, but you have something being squared. So here we have 2 times stuff squared plus 4 times the same stuff equals 6. Now remember that we can use our quadratic formula or the quad program in your calculator if we get it equal to 0 first. So the first thing I would do is get it equal to 0. So same idea. Just subtracting that 6 over. And then we can run our regular quad program, but using the coefficients of the stuff. So right here, our A would be this 2, our B would be the 4, and our C is now this -6. So we're going to run quad. Okay. So you go to quad in your programs and punch in your A of 2, your B of 4, and your C of -6. Make sure to use that little negative on the bottom, so not the one on the side, but that little negative on the bottom, and hit enter. Remember that it'll give you first the rounded decimals. In this case, they are pretty numbers, but if you ever have decimals or anything weird, if you hit enter that second time, it'll give it to you in exact form. So it says that the answers are 1 and -3. Now, normally when we had a quad program for just an x squared and 4x minus 6 kind of scenario, that would be the answer for x. X would be 1 and x would be -3. But since we didn't just have x, sorry, all tongue tangled, we had the whole thing, the stuff, t plus 3, that is what is equal to 1 and -3. So t plus 3 is equal to 1. T plus 3 is equal to -3 because that is the stuff that was being squared. So we have just one last little step to finish this up. Subtract 3, just a tiny bit of algebra to solve it for t. To find that finally the variable itself would be a -2 or a -6. So remember that you can always go back in and check your answer by plugging those in. You would find that those would actually come out to be the 6 from the original equation. So same idea, just making sure you really understand our trick here. Here's the same idea, except instead of just an x squared, we have x to the 4th. So I kind of focus here on the middle to see what's going on. What is our typical variable? So right here we saw the stuff was the t plus 3, and it was the t plus 3 squared, and then just the t plus 3. So here what we have is actually x squared, because x squared squared is x to the 4th. So just like the last one, we have stuff. So I have stuff squared minus 26 stuff plus 25. So again, we can use our quad program. But instead of going right to our final answer, our A of 1, B of -26, and C of +25 is going to give us not the answer for the final variable x, but the answer to the stuff, the x squared. Scoot this up just a little so we have one more line to work out the final answer. So again, if you pull up quad and punch those in, it'll give you a 25 and a 1. So to find our final answer, we would have to square root both sides. But remember, when you square root both sides, you have to do that plus or minus. So the final answer would be x equals plus or minus, positive or negative, square root of 25, which is 5, and the square root of 1, which is still 1. So we end up with 4 answers, just like we would expect for an x to the 4th problem. So the reason we did this refresher is because now we're going to do it with the trigs. This was something that we couldn't just FOIL our way out of and try to use a more normal quad program. So cosine is his own thing. Cosine is our stuff this time. So here I have 2 cosine squared, 2 stuff squared, plus stuff minus 1. So in that same idea, we could run it through our quad program. So our A would be the 2, our B would be this understood 1, and our C is the negative 1. So running our quad program again, with an A of 2, a B of 1, and a C of negative 1, gives us, again, the decimals first, and then if you hit enter one last time, it'll give you an exact form, the fraction of positive 1/2 and negative 1. Now again, it didn't give us the final answer for x, just like it didn't up here. We had one last step to clean it up. It gave us the answer for the stuff, the quad, the thing that was quadded. So the stuff squared plus 1 stuff. So that means right here, not just x equals 1/2, but cosine of x equals 1/2. And cosine of x equals negative 1. So now we have a problem just like we've been working in the last chapters. So back all the way even into chapter 1, we found places where cosine of x would equal 1/2. We could use our unit circle. So these would be in 2 specific places. They would be positive in quadrants 1 and quadrant 4. So remember that cosines are positive. They're like the x's in quadrants 1 and 4 over there on the right. So if you look at your unit circle, you would find that that is at either 60 degrees, or looking at the instructions in radians right here, that would be at pi thirds. And in quadrant 4, it is equal to positive 1/2 at 5 pi thirds. Okay, cosine is equal to a negative 1 exactly. Okay, remember it's like the x value, so that'd be all the way on the left at 180 degrees, or pi. Now in this problem, you'll see the question phrased in one of 2 ways. So it might ask you to find just the solutions within one full circle, or it might ask for all. And don't worry, it's not as intimidating as it sounds originally. So remember that we learned it way back in chapter 1 that if you were at any point on the circle and you went full circle, all 360 degrees around, you'd land in the exact same spot because it's just a huge circle. So knowing that the coterminal angles could always be found by going 360 degrees or 2 pi's all the way around, I always recommend finding these answers first, because the all radian solution answer will be those exact same numbers, the pi thirds, the 5 pi thirds, and the pi, with all of the coterminals, which can be found by going 2 pi all the way around any integer amount of times. So you could go 2 pi forward, you could go a couple of times, you could go 100 times, or you could even go backwards 2 pi and you'd land in the same place. So what they do is they write it as 2 pi k, letter K, and they specify that K is an integer. So K couldn't be like 0.75, it has to be an integer number. It could be positive or negative, but it has to be an integer. Most of that is written up for you in XYZ. So you just have to select the period of 2 pi. So just remember, since we were dealing with cosines, to land in the coterminal spot, to go one full period and land in the same spot, is 2 pi. So these would be the answers for part A of this problem. And then these would be the answers for part B. So even though they're a little bit out of order, like I said, finding these first is helpful because the answers for part A are the exact same things plus 2 pi k. Okay, let's try it again. I know it might not be super clear just yet. So this one, notice I don't have a quadratic, so it's not exactly like those last ones, but it's that same idea where I'm using sine as basically the variable. So if this were square root of 3 plus 6x equals 4x, we would know to solve it for x. It's the same idea. So we treat sine like our variable. So I'm going to get my signs together, because remember, I can't solve for a variable if he's in more than one place. So just like I would if he'd been an x or anything, that's going to give me the square root of 3 equals, cancels over here, so that's all alone. 4 minus 6 is negative 2. So if I had 4 of something and I took 6 of that same thing away, I would be in debt by 2. writing's a little sloppy there, so that is sine of t. Now remember, I'm treating it like a variable. This is -2 times the variable. So remember to undo a times, I divide. So I divide both sides by that -2. And sure enough, that looks like something familiar on our unit circle. So basically, I'm looking for the unit circle solution of -√3/2, looking specifically for the sines. Okay, so again, we're in the radian form right here. So I'm going to look at my radians on the unit circle. I know that sines are negative in quadrants 2 and 3. Sine is like y, so it would be negative on the bottom part of the graphs, quadrants 2 and 3. Nope, I'm saying that wrong. 3 and 4. Sine is negative in 3 and 4. I was thinking cosine. Quadrant 3 and quadrant 4. There we go. Okay, so looking in my graph, I see that that is going to be at, let's see, thinking radians, 4 pi thirds, 60 degrees past 180. So 4 pi thirds. Okay, and then also one more over in the quadrant 4 of 5 pi thirds. Now again, these would be the two solutions of B, the all within one full circle, okay? And then to find all radian solutions for part A, I just take those two things and add on the period of sine, which again is 2 pi. Okay, so those would be the answers for part A. So tangent, now here's a little bit different one. Remember, sine and cosine both had a period of 2 pi. We know tangent has a period of pi, so just keep that in mind right at the very beginning. It's going to be slightly different on this part. So again, I'm going to treat tangent just like the variable. I'm going to isolate the variable just like I would if it had just been an x. Subtract the 2. And since that is 2 times tan, I will divide by 2. Luckily, that works out to a pretty number of -1. So I'm just looking for where the tangent is equal to -1. Okay, so tangents are negative. Remember, tangents are kind of the weird ones. They are negative in quadrants 2 and 4. Okay, so looking on my unit circle, I see that it is -1 exactly. Where the sine and cosine match in quadrant 2, that's going to be right there at 3 pi fourths. Okay, and then in quadrant 4, that's going to be there in 4, 5, 6, 7 pi fourths. Right before 8 pi fourths. So again, this is the answer for part B. And right here in part A, be careful. It's just a little tiny bit sneaky. So like we said, normally we would just tack on the 2 pi k because the period of sine and cosine is 2 pi. But watch this. If I tack on the period of tangent, which is just pi k, then really this is all I need, because think about it. Pi is 1 whole pi, right? 4 fourths, 1 whole. So if I took 3 fourths of something and added on 1 whole, 4 fourths, that would be 7 fourths. So what that means is that 7 fourths is included in this answer right here, because 3 fourths plus 1 is 7 fourths. So if I wrote 3 fourths plus pi k and 7 fourths plus pi k, then really it's redundant. I'm putting the 7 fourths in there twice. I'm listing all of my values, my answers in there twice. So the only one I need is this guy right here. And the main time this sneaky thing's going to come up is with the tangent, because tangent's period is smaller. So it kind of incorporates the answers that you got already. But these ones did not overlap. If you actually took 4 thirds plus 2 wholes, it did not equal 5 thirds. These would be different solutions in different positions on the circle. So that's why these are slightly different. All right, one more. Now this one looks like a mess because it has sine and cosine together. But just like you would have if it had been a problem like this, a plus 2ab equals 0. Sorry, my pen's messing up. There we go. We would know to factor out what they had in common. So I would pull out that a that they had in common. Then I'd have 1 plus 2b. So same idea. We're going to pull out not the variable a that they have in common, but the whole trig function sine. So I'm going to factor out a sine. And if I factor a sine out of sine, that would leave me 1. If I factor a sine out of 2 sine cosine, that would leave me 2 cosine. Okay, now I know that might seem a little bit weird, but think about if I distributed it back in. 1 times sine would be sine. 2 cosine times sine would be 2 sine cosine. So I've just pulled it out. I've undistributed it. Okay. Now the reason I did that is because back in the old days, before we used our quad program quite as much, the idea was that we would want to try to factor, and then we set each of those factors equal to 0, because the principle of zero product says that anything times 0 is 0. It's the magical number, the only one that does that. So if I could set this sine equal to 0, anything that turned this equal to 0, it wouldn't matter what was in here, because anything times 0 is 0. Same idea, if I could make this inside stuff right here come out equal to 0, it wouldn't matter what sine was because anything times 0 would equal 0. So sine of 0 happened on the unit circle in 2 places. It happened at 0 exactly, and over there at 180 degrees or pi radians. Since we're still doing pi, let's practice that. Now this one I have just a little bit more work to do, basically like the blue and purple ones. So I do need to finish solving. So I'm going to subtract the 1 and divide by 2. So it really didn't matter that we ended up with the 2 different trig functions because it just ended up as 2 completely separate little algebra problems. So this one says that I'm going to have a cosine of x equal to -1/2. And remember that cosine is negative in quadrants 2 and 3 over there on the left. So -1/2, looking at my unit circle, would have a cosine of 2 pi thirds. Quadrant 2, and then in quadrant 3, it would be 4 pi thirds. Okay. Now these 4 answers right here, x equals, there you go. Okay, would be the answer again for part B. We always kind of found those first. Okay, so that means the answer for part A would be those same things, same 4 numbers, plus 2 pi k. Okay, because this period for both sine and cosine is 2 pi k. So it'd be 0 plus 2 pi k and pi plus 2 pi k. 2 pi thirds plus 2 pi k. Sorry, distracted myself. 2 pi thirds plus 2 pi k, and last 4 pi thirds plus 2 pi k. Okay, now again, these are in completely separate spots on the unit circle. You couldn't just kind of jump an even amount to get from here to there and then back around again. But there is kind of a little sneaky thing right here. You might have noticed that these are both exactly pi away from each other. So if I went from 0 to pi, I went 180 degrees, I went pi radians. And then if I wanted to get from pi back to 0 or to 360, I would have gone another pi or 180 degrees. So just like these 2 right here, they're kind of special because they're evenly spaced from each other. They're exactly halfway across the circle. So this right here is acceptable. This is an answer, but you may notice on XYZ, it doesn't give you those 4 spots because these are evenly spaced. So a more concise way to write these 2 answers right here is instead that it's 0 plus just pi k. They're exactly halfway across from each other, just like these two were. So if you found these two positions on the unit circle, draw them out real quick. So that would have been exactly here and exactly here, halfway across. Just like 0 and pi are exactly halfway across. So they're special. Okay, so that has an easier way to write it, a more concise way without writing as many plus 2 pi k's. So these would be your 3 final answers for part A. Okay. So these two are your answers for part B. These two are your answers for part A. All right. Now, those were all nice, pretty ones on our unit circle, so we kind of wanted to keep that handy. Now, what if they were messier numbers that were not exact, pretty, pi thirds kind of things? Well, we can still use our calculator. This time we get to use that arc sine and arc cosine button. So make sure you've cleared it out of the quad so you're back on your regular home screen, hitting enter if necessary. And they switched us back to degrees just to kind of keep things consistent. And I'm pretty sure all of the problems were in degrees at this point. So once they get past those pretty unit circle ones and you see that it switches in degrees, double check your calculator mode. So right next to the second button, hit the mode and make sure that you are in degree mode, not radian. So just double check that because that is a common mistake and that'll give you the correct answer but in the wrong form and it won't recognize it on XYZ. All right, so same idea. We start off the same just like we did on the last page. So I treat sine like a variable. Switch him over here. Remember that that is like 1 sine. So 9 of them minus 1 will leave you with 8 of them. So right there, you can see why we don't get to use our unit circle anymore because now I have sine equal to -3/8. And that is not one that we have marked on our nice pretty unit circle. Okay, so from there we get to use our arc sine. Now, we've done problems like this before, so really the only new stuff was this little bit of algebra isolating the sine. So I kind of gave you a whole section on just that. But what we found when we were doing problems like this is that it helped just to always stick with finding answers in the first quadrant. So right here, this problem, a negative sign would happen in quadrants 3 and 4. Sign is negative in quadrants 3 and 4. So I gave you this nice chart, which I've included in this note packet. Sorry. Sorry, my computer travels slow. There we go. Okay. Okay, there we go. On the very last page. So you can flip to the very back of your note packet and kind of keep this little chart handy. So like I said, it helps to just always find the arc sine and arc cosine of quadrant 1 only. And then you can use your chart to go from quadrant 1 into whichever quadrant you need to after that. So we're going to do that. So keep that chart handy. So we said that this one, before I accidentally Control-Z'd my quadrants away, should land in quadrants 3 and 4. But to find the actual number with my calculator, I'm only going to find the quadrant 1 answer by taking the arc sine of +3/8. Okay, so not sine, but arc sine. So hitting on my calculator second and sine so that it has that little -1, looks like an exponent of +3/8, 3 divided by 8. Okay, making sure again that you're in degree mode, you should get an answer of 22.024. So of course there's more decimals, but around there. All right, this is not your final answer because this is the answer for quadrant 1. By making it positive, I forced my calculator to find the quadrant 1 answer because it's easiest to go from quadrant 1 wherever we need to go. So if I wanted to convert my quadrant 1 answer to the equivalent quadrant 3 answer from quadrant 1 to quadrant 3, I'm going to take that answer and add 180. Now if I want to take my quadrant 1 answer and find quadrant 4, I'm going to take 360 minus that answer. So I'm going to do these two things, 180 plus that answer, 360 minus that answer. because that will give me the equivalent sign in those quadrants. Okay, so I take quadrant 3, 180 plus that 22.024. And for my quadrant 4, I take 360 minus that 22.024. Okay, this is going to give me the final answers of 202.024 and 337.976. Now I know that might seem a little bit weird jumping around the quadrants. We had a whole lesson about that. So if you need to jump back to that earlier lesson, finding the not coterminal angles, but the, oh, I forget the name, the quadrant equivalents. Basically what we did is we found that 22 would have the same sign over here in quadrant 2, right here. In quadrant 3, it would go straight across, right there, and form a straight line. In quadrant 4, it would go down the same amount that this one went up. So all of these would have the same sign in that equivalent quadrant. But of course, quadrants 3 and 4 would have the same sign value, but negative, which we know this one had, negative sign value. So again, we had a whole lesson on that. If you need to jump back to that lesson, refresh. Okay, so let's try that again right here. So again, first, the only real new stuff is just that little bit of algebra, getting cosine all by himself. So I'm going to bring my cosines together. I'm going to get my numbers away, all of the constants. Okay. Careful that doesn't cancel. I know it's tempting, but -2 minus another 2 is -4. 4 minus 3 is just 1. There we go. So this one right here, again, I would just enter it as the positive. So I go second cosine of +4. And you hit enter and your calculator explodes. Just kidding, but it didn't like it. It gives you an error because just like remember from our unit circle, all of those cosines were between +1 and -1. You can't get a cosine that's 4, the whole number 4. 0.4, yes, but not 4. So this one gives you an error, which means there's actually no way that you could plug in a theta, an angle right here, and make these two sides balance out. There is no answer that would make this happen. Does not exist. There's no angle that would make this equal that. That was easy, right? But be careful, that's a pretty rare one. So don't put does not exist every time you don't know an answer. It's very rare, okay? It might not even be on the test. It might, but it might not. So don't overuse that one. Okay, now this one again, just like we did on the previous page, we can use our quad program. Our A would just be that understood 1, our B would be the -5, and our C would be the -4. So I go to programs, I go to quad, enter that in, 1, -5, -4, make sure to use that little negative, and it gives you the decimals. Okay, remember those are not your final answers, those are the answers for sine. And then just like the red one we just did a second ago that says that we cannot take a cosine and get an answer above 1, this answer of 5.7 is out, okay, because it's greater than 1. So I know he's out. I don't worry about him. He's greater than 1. That would just give me an error. I know it right away. I don't have to punch it in. So the only one I really care about is this guy, which is -0.701.562.1187. Okay, I'm writing down the whole entire number because rounding is very, very crucial at this point. Okay, so if you round off a number, you might get a completely different answer. It makes a really big difference right here. Just write down that whole number. Don't miss a problem just because you didn't feel like writing one more number on your paper. All right, now just like this one right here, the red or the blue, I'm going to need to do the arc sign, but just like this one in the blue, I'm going to do the arc sign of positive. Okay, so I'm going to type in positive on purpose. I'm ignoring this negative because I'm going to come back for that negative by saying that I'm going to switch to, just like the blue one, answers in quadrants 3 and 4. Okay, so when I go to quadrants 3 and 4, that's what makes the negative be there, because in quadrants 3 and 4, the sign is negative. Okay, I'm going to make sure to type in the whole thing, not leaving off any decimal points. Don't get lazy right there at the end and mess the problem up just because you didn't write one more number down. Okay, so hit that arc sign, type in all of those numbers, and you should get, now here you can round, 44.55. Okay, I can round here because I'm almost there. This is basically the degree answer. I just have to get it to the right quadrants. But when I'm doing this arc sign, leaving off even one of these decimals can really affect things. So just like here, I want to go to quadrants 3 and 4. Quadrant 3, I do 180 plus that answer. Quadrant 4, I do 360 minus that answer. Okay, because those are the places that sign is negative. Okay, so I type that in, and that's going to give me 224.55 and 315.45. Now I know the first time through trig, it kind of seems very arbitrary. We're making up all these words, sines and cosine. It doesn't really make sense. So just to kind of double check yourself at this point, just to try to really click the pieces together, type this in. So in your calculator, getting past that quad screen there, hit enter one last time so you're on your blank screen. Let's type it in. So I use parentheses, and let's just do the top one here, the 224. So I go parentheses, just open parentheses, and then I hit sine, not arc sign, sine of 224.55, close for the sign, close so that I can square the whole sign. Okay, so it should be parentheses, sine, that number, close, close, and then square. Okay, all right, I arrow down and I say -5, and then again, parentheses, sine 224.55, close, close. Okay. So I did -5, open, sine, close, close. All in the same line. I'm still doing the same line. I haven't hit enter yet. -4, enter. Okay. And the answer is basically 0. Okay, there's a little bit of rounding error there, but remember this little e right here on the end is that scientific notation. So it's saying that this is actually 0.0000196, blah, blah, blah. So that means that answer is 0. Okay, it's really, really close to 0. So you could try it again with this one right here. So that means these are the two angles that would make this equation turn out to be 0. So we did have a little bit of rounding error, which is why it wasn't exactly 0. You could have tried to minimize that by typing a more exact angle in, but that right there is the angle. If I tried it with the sine of 30 degrees, it wouldn't even be close. Okay. All right, one more time. I know this seems a little weird, but we're getting it. Okay, just take some practice. So again, we can't use our quad program until it's equal to 0. So I'm going to move this guy over here. So I'm going to add that 3 cosine squared over. Careful not to combine unlike terms. So this would be 3 cosine squared plus, because he's positive, 2 cosine. Okay, now I can use quad, where my A is 3, my B is 2, and my C is -4. So I go to my programs, I go to quad, I type those in, 3, 2, and -4. Okay, it gives me the two decimals. Now remember the first one right here. Sorry, my pen is messing up. Cosine of theta. There we go. The first one, which was the decimal, 0.8685. Write the whole thing, 170918. Okay, he's good. But this next one, the cosine of theta, might also equal negative 1.5. That one's out, okay? Remember, it's bigger than 1. In this case, less than negative 1, but it's greater than 1 whole. The absolute value is greater than a whole. So he's out, okay? Greater than 1. All right, so we only want the little decimal ones. So this one's already positive, so I don't have to change its sign. I always want the positives because I always want quadrant 1. But then once I get one of the answers, where else is cosine positive? Cosine is positive in quadrants 1 and 4. Okay. So let's type that in. It's the arc cosine. Make sure to hit second. Make sure to type in all of those decimals. Don't get a rounding error after all that hard work. There we go. It'll give you the quadrant 1 answer of 29.71. Round there because we're almost there. So to get the equivalent quadrant 4 answer, just like we did right here, we would go 360 minus that. It's one of our 2 answers because this time we did want quadrant 1. And the second answer in quadrant 4 was 330.29. There we go. Okay, now in all of these, they did ask for all answers. But remember, just like we talked about, since they are sines and cosines, the all answers part A of all of these would just be tacking on the plus 2 pi k. Okay, there weren't any sneaky ones in here that had, a special straight across. These were all in different spots on the circle. No tangents, no weird zeros or ones. So all of these would just have the regular plus 2 pi k. Okay. All right, so it takes a little bit of getting used to. Like I said, just be careful that we always do this arc sine or arc cosine of the positive. That just makes life easier so that you can use this chart to go to whichever quadrants you want the answer to be in easier. Okay.